I'd like to introduce an interesting research project now that's relevant to several themes in this module. And it's concerned with the acquisition of language by children, or rather by one child. It's called the Human Speechome project. And it comes from MIT Media Lab, where an awful lot of cognitive science and artificial intelligence work has had its home. The name is specifically chosen to call to mind the Human Genome project, which was a very heavily data-driven approach trying to map out, to record in detail every single element in the human genome. This project was about 15, 20 years ago now, fundamentally changed our idea of genetics. And the scientific mindset that's brought to bear in the Human Genome Project is not unlike that in the Human Speechome Project, and that is to exhaustively record something absolutely central to being human. The scientist in question is Deb Roy on the bottom right there, and he follows in a long line of prominent scientists who have actually done some of their best work studying their own children, which is a bit odd. So Charles Darwin did this. Jean Piaget did this. He didn't put people in laboratories, really. He studied his own children. Sigmund Freud did this. So there's some notable examples here of people studying their own children. The child in question was Deb Roy's first child. And the goal of the project was to capture the entire linguistic output and linguistic environment of this child over 3 years. That sounds ambitious. It is enormously ambitious. It was a major undertaking. Deb and his wife Rupa thought very hard about this, and the project was a long time in designing. Went through very thorough ethical review. The results are still being analysed, even though the data collection ran from 2005 to 2008. The project required them to rewire their entire home, putting in video cameras, overhead video cameras with fisheye lenses in every room, putting microphones in every room, clearing out the basement and putting in a data farm in the basement, because they were capturing audio visual data constantly streaming over 200 gigabytes a day, and this is 15 years ago. This is an incredible amount of data. So they had 140,000 hours of audio visual data at the end of this. Now, the child was not absolutely confined to the house for 3 years, but those 3 years were in that period. The child was young. This is the child around age 2 and 3, beginning to be proficient in language. I'm not sure exactly what age the child started, probably 1. And one of the first problems you have when you have this kind of data is, how do you use it? This is what a lot of the data looks like. So here's a view from a fisheye camera in the kitchen, and there's Deb Roy himself and the infant. What do you do? Well, there was major advances made in the context of this project in the analysis of audiovisual data, in extracting salient elements from all that, as much as possible semi-automatically, but there was a lot of people working on this project. And just to give you a flavor of the data, here is something that would never have otherwise been possible. So we can listen to the development of the word water as uttered by one child. Now, if any of you have interacted with very young children, they often use strange words. They often don't use the canonical words. They say gaga or bleh. And parents typically know what they mean. And indeed, the child's first production of water here sounds like gaga. The unique nature of the database means we can go through and find every instance in which the word is understood to be water and play them back to back. And what you hear is the word. You hear the word coming into bloom. I'll just play this for you. I think it's a remarkable recording. eventually, doesn't he? It takes a long time, but you can hear the word coming into being. So that's kind of remarkable. That was just sound. You can do the same thing audio-visually. So here's just a little excerpt focused on the moments of occurrence of the word ball. So one thing you can do is you can look to see, where does a word occur? What room was it in? Who was there at the time? What time of day was it? Questions that are otherwise don't exist. And so on. So this is an extremely rich data set that allows you to ask questions that you couldn't otherwise have asked. We don't have time to do a full dive on the kind of research questions that arise here. I'll show you one of the very first results because it's very relevant to something which we have already met in this course. You've now listened to the word water and the word ball. And for each word in the child's vocabulary, there's a moment at which that word is uttered for the first time, whether it be in the canonical form or not. So the first time the child says gaga, understood as water, that's the birth of the word. So we'll call that the birth of the word. Now each word will have a different birthday. So the word for truck appears on Friday, and the word for bread appears 2 months later, and the word for bed appears the previous week. So every word has its own birthday. What you can do is, for each word separately, you can ask, how complex were the utterances in the environment of the child prior to the birth of the word and after the birth of the word for sentences containing that word? Now that's quite a complicated question. Make sure you understand what we're asking here. For each word, we want to know how complicated were the environmental sentences containing that word before it appeared and after it appeared. And we can align this for all the words, because let's take 0 as being the birthday of a word. We can ask about sentences in the preceding months and in the following months. How do you measure the complexity of a sentence? Well, there's no single standard method. This is a very crude initial approach taken here, which is just how many words are in the sentence. It's a very crude approach. That's fine. What we see is shown in the plot here. This is for very many words. And there's a curve fitted to the dots. It's a fairly good fit. And the error bars are shown. So there's a lot of variability in the data, but there is a clear trend. You can see from this that before the child first utters a word, the environment is changing and sentences containing that word are becoming simpler. Once the word has been birthed, that effect goes away. That is remarkable. That there is absolutely no way anybody could be conscious or aware of this. This is happening on a different time scale for each word individually. So what's revealed here is a dance between the child and the social and linguistic environment, of which neither party is aware, but where the environment is ready for the emerging capacities of the child. Now, in this unit, we've already met Vygotsky and his zone of proximal development. A zone of proximal development, you will recall, is a term used to refer to the fact that the child in an appropriately structured and social environment is capable of things that it cannot yet do alone, but that it later on will be able to do alone. That's a theoretical way of viewing the learning child. But here are some data that show that there is indeed a very, very delicate and invisible dance between the infant and its environment, such that the environment supports the infant at every stage. This is as close as you can get to an experimental verification of the idea underlying Vygotsky's zone of proximal development. But this study and these results are relevant for another theme that we've already picked up. This incredibly ambitious project allowed for the first time a direct observation of the linguistic environment of the child. Now, this notion of a linguistic environment, the words and sentences and interactions that you encounter as an infant, has played an extremely important role in arguments for the birth of generative linguistics. It was Chomsky who claimed that there was a problem of the poverty of the stimulus. One of the main reasons Chomsky argued for a universal grammar and for an inbuilt language faculty is because he claimed the linguistic environment was just too poor. He understood the linguistic environments to consist of those peculiar utterances that caregivers give to infants. Oh, look at the little boy, he's got his daddy's nose. That kind of thing. And he simply decided that that was not much good for learning language, so it must be all inside the child. This experimental project actually decides to look and finds the situation is not nearly as simple as was declared by Fiat from Chomsky's armchair. So this is relevant to us for very many reasons. Right, we have one more video to do in the topic of development.